And it's a lightning talk, and we've got loads of slides, so we're just going to bang through it. Cool, so this carries on from Caelan's talk, where he was talking about bucket-based artifacts, and we're going to try and persuade you that he's wrong, and that you should use volumes instead for your artifacts. Caelan's also my boss, so I might not have a job at the end of this. So yeah, I work for PipeKit. As he's already explained, we offer a control plane for Argo workflows to let you do big data stuff, basically. We also contribute heavily to Argo Workflows open source. And I basically live in the Argo Workflows Slack channel. So if you've asked a question in the Slack channel in the last 2-3 years, you've probably spoken to me. Yeah.
Great. And I'm Lukonde Mwila, or you can call me Luke, and I'm a developer advocate at AWS, specifically part of the EKS team, and also friends with the folks at PipeKit, and contribute as much as I can to the Argo ecosystem, specifically Argo CD.
So this slide is very similar to what Caelan showed. We're trying to address the same problems about sharing data between steps in workflows and between workflows themselves. And Caelan also highlighted the kind of different categories of data. So you've got persistent data you want to keep as long as possible. The semi-persistent data that you don't really care if you lose it, but if you do lose it, you're going to have to do some work to get it back. And then transient data that you really don't care about. You just need to have it for the life of your workflow, and then you can let it go.
Great, so Caelan already went into detail about the different storage options, so I'm just going to focus on EBS and EFS. So with EBS, the challenge that you have here is that it doesn't allow you to carry out tasks for read, write, and many. However, it is really good for persistent storage, and if you want to use it as a backend solution, as a backend for solutions like MinIO. And then EFS, specifically in the AWS context, does give you the read, write, and many capabilities. However, it does restrict you to that particular environment. That's something you need to be aware of. And also, it can be a little bit tricky to set up, so we want to focus on a simpler solution.
Yeah, so in the same way that MinIO is kind of an on-prem self-hosted solution for S3, we're advocating the NFS server provisioner to do the same job that EFS can do. So NFS server provisioner, there's quite a few out there. We use the one that's on the really long link at the top. You know, good luck writing that down. But essentially, all it does is it gives you a pod and a storage class. And you reference the storage class, you get your PVC, and magic happens, basically. And it can turn an EBS disk, read-write once disk, into a rewrite many disk. Even more magic, you can have no disk behind it, and it uses your ephemeral storage on your node. So it allows you to use that spare disk that you're already paying for to handle the transient data loads, basically. There are no demos in this because we're on a lightning talk. The small link at the bottom has loads of stuff that you can go and look at. So you saw Caelan's example of a full CI workflow using buckets, which is wrong. I've got the same thing, which uses disks in exactly the same way. So you can run the two side by side and see how they work in your local environment.
Great, so just a quick overview of how you can actually get started with the NFS server provisioner, specifically for semi-persistent data. You deploy the Helm chart, which will spin up a pod, as well as the persistent volume claims and a storage class, and then those PVCs would be used to reference the storage class. And the point here, obviously, is to actually make sure that you have the PVCs and the relevant volumes created beforehand, and then you'd simply mount the volumes in your specific workflow.
So at PipeKit, we install NFS server provisioner twice, the way that Lukonde just said, and then this way, which is exactly the same, but without the disk behind it. So it's then pointing at your ephemeral storage instead. So we use this for the transient data side of things. The workflow just spins up with the volume claim template, creates a PVC on the fly, does workflow stuff, and then just drops it all at the end. So you save. Here's a really quick example just showing the difference in the setup between the two, which probably looks awful on the giant screen. Again, you can do a diff in the GitHub repo if you want to, so don't worry too much. I just wanted to highlight that it's really easy to flip between the two. So again, don't listen to my boss.
Right, so real quick cost comparison over here, and this is just based on the experiments that were run. It may vary depending on how you carry this out. So despite the fact that the particular approach that we're following would definitely work well for performance and at speed, it is not the most cost-effective approach. As you can see over here, S3 definitely worked out to be the cheapest one, whereas EBS was actually, using EBS as your backend was actually the most expensive one, and we see EFS fall somewhere in between S3 and EBS.
So at this point, my talk's not looking great because, yeah, we've just proved ourselves wrong. So then I started looking at speed. I've written a really simple workflow. Again, it's in the repo. All it does is it creates a 10 gig block of data, stores it in the artifact repository of your choice, then does a second step that runs 3 steps in parallel to create 10 more gig of data. So overall, we're generating 40 gig of data as fast as possible and just analyzing it through. That's all we're doing. It's a really dumb test, but hopefully it highlights something. And here were the times. So this slide is why Kaelin's wrong. So S3 took 7 minutes to handle that 40 gig of data. Most of that was tarring all the stuff up. So, okay, if you actually listen to his talk, then obviously you could just turn the tarring off and the argument might be slightly lower. But so 7 minutes for S3. NFS Server Provisioner took 20 seconds to do exactly the same thing. So if you're working at scale, this is a real key thing to be paying attention to, basically.
Great. So real quick, first thing to consider with a couple of tips is the amount of storage that you'll actually need. So consider fattening or increasing the storage disks for your particular nodes. Another thing would be to actually consider, if you've got a lot of read and write tasks that you're going to be carrying out, is to have the data copied from your NFS disk to ephemeral storage beforehand. And then, like Tim has already pointed out, we're installing the NFS Server Provisioner twice. The first time is for the EBS backend for semi-persistent data, and then the second time is for ephemeral node disks for transient data.
This is a screenshot of our actual CI at PipeKit. The content doesn't really matter too much, but you can see there's a lot of parallel stuff that we do. So we're doing container image builds, we're doing binaries from Go, we're doing Go tests, and all that happens in just over 3 minutes for us. So before we used all the nice disk magic behind it, it was taking about 15, 20 minutes. So that's a real world example of how you can save your time.
Yeah, and just to wrap up again, Kaelin covered the 3 different artifact categories for persistent data, semi-persistent data, and transient data. So for a persistent data approach, we definitely recommend that you follow the route that he was demonstrating with a bucket-based approach, whereas for persistent data, for semi-persistent data and transient data, we'd recommend following this approach with the NFS Server Provisioner.
Cheers. Gonna find out if I got a job.